Hi, I'm Miss Hall, and this is Lesson 54, Dividing Rational Expressions. To divide one rational expression by another, multiply the first rational expression by the reciprocal of the second rational expression. Rational expressions are closed under non-zero division. Here's the new piece that we are adding. We are beginning today with division. And the first thing we're going to do is we're going to turn division into multiplication by multiplying by the reciprocal. So while in lesson 53 we had 3 steps, today we're adding a step to the beginning and we have 4 steps. So the first step we're going to do is we're going to rewrite the problem as a multiplication problem. Let's do this with example 5. So 7x over 2x minus 10 times, so it was division, we'll change it to multiplication and then multiply by the reciprocal expression, which is x squared minus 11x plus 30, x squared minus 6x. Second step is to factor the numerator and denominator. Second step, 7x stays, and now there's a GCF in the denominator of 2, and we get x minus 5 left over, times, let's factor this quadratic trinomial. I'm looking for 2 numbers that multiply to positive 30 and add to negative 11. That's negative 5 and negative 6. And I have a GCF in the denominator of x, so x, take it out, you're left with x minus 6. Third step, divide out common factors. So let's see if there are any common factors to the numerator and denominator. We have x minus 5, x minus 6, and x. Now the final step is we will write what's left over and restrict the domain. What we have is 7 over 2. And when we restrict the domain, we're looking at the factors that we eliminated in the denominator and checking for the x values that make those factors 0. So it's 6, 0, and 5. And so x cannot be equal to 5, x cannot be equal to 0, x cannot be equal to 6. Those are x values that make the expression undefined. Example 6, dividing a rational expression by a polynomial. So the one little thing you should know is that a polynomial can be rewritten as the polynomial over 1. And now we go through the same 4 steps. We'll first rewrite the expression as multiplication. So we have 6x squared plus x minus 15 all over 4x squared times 1 over 3x squared plus 5x. 2, we're going to completely factor the numerator and denominator. This one has an a value greater than 1, so I'm going to have to do some additional work here. I'm going to put the product of a and c, which is negative 90, and then b down here, which is 1. And so I'm looking for 2 numbers that multiply to negative 90 and add to 1. That's 10 and negative 9. We rewrite 6x squared. We have minus 15, and I'm going to add the 2 linear terms of plus 10x minus 9x. Now I'll factor by grouping. I'll take out a 2 x and leave 3x plus 5 behind. I'll take out a minus 3 and leave 3x plus 5 behind. Great, and this can be rewritten as 2x minus 3 times 3x plus 5. And let me rewrite that over here. So I have 2x minus 3 and 3x plus 5 all over 4x squared times 1 over GCF of x comes out. We get 3x plus 5. That was step 2. Step 3, divide out common factors. We have 3x plus 5. Now I will rewrite and restrict the domain. In my numerator, I have 2x minus 3 over 4x cubed. In my restricted domain, x cannot equal. I got rid of one of the factors. Let me find that x value up here. So when 3x plus 5 equals 0, the denominator is undefined, so I want to restrict that from the domain. I have 3x equals negative 5. X equals negative 5 over 3 will make that equation true, so x cannot equal negative 5/3. Alright, so the first thing I'm going to do is rewrite this division as a multiplication problem. We keep the first rational expression as is. And multiply by the reciprocal of the second expression. And now I will factor completely the numerator and denominator. Let's say two numbers that multiply to negative 22 and add to 9. Plus 11 minus 2. The denominator is a difference of squares. So the factors are x minus 11 and x plus 11. Nothing to factor in the second expression. Now it's time to divide out common factors. X minus 2 and 2 minus x are very similar. I can make the numerator look like the denominator by rewriting this as negative 1 times 2 minus x. And now I can divide out this common factor of 2 minus x. What I am left with is minus 1 over x minus 11, so negative 1 over x minus 11. That is not an answer choice. So here's what I can do. I can multiply this fraction by negative 1 over negative 1. When I do that, I get 1 over 11 minus x, kind of doing the reverse of what I did here. And all I did was I multiplied my final answer by positive 1. And now I have answer choice D, or 4. That is the correct answer.